Hello everyone. This should be the last part of this. I've got it all together on my little Edison blue Amberol record player. So I'm gonna show it working. I totally cocked up a few things I found out, and anyway, I've altered the PCB on PCBWay to suit. Oh, yeah, well, let's just stop that a minute. Oh, no. I'd forgotten something, but no, I haven't. Right. Well, yeah, if you know me by now, I always forget something. Right, this is the little knob I made. I've just made it out of the same stuff I built the stuff out of. Just 3 pieces glued together. But I've left it off because I wanted to show you. I messed up the amplifier here. Actually, what I'll do is, I don't mind showing off my mistakes because this is the whole idea of making a prototype is to find out what you've done wrong, and eventually you'll get it right, and then you alter it for the next one. So there's a few things that I've had to add and change to get it working, and I just want to go through those things. So let me get my microscope out so we can have a closer look at some of the things. Right, let's start with the audio amplifier. What I've used here is an LM4871. This is only a 3-watt amplifier. Basically, I haven't put a heatsink on behind it on the PCB either. But there's one thing I forgot to do, and that is put a resistor and capacitor on the input. Obviously, we don't want any DC getting there, so I should have put a capacitor where we're coming from. These are the pins coming from the stylus. So one obviously goes to ground, but the other one goes to the input of the microcontroller. So you can see I've cut the cable there at the trace. Hang on, where's my big hand? Have I still got that? Just give me a minute. There we go. Right, now I can point to it. Yeah, you can see here where I've cut the trace there, look. So I've cut through the trace, and then I've had to put a bodge wire in here. And the bodge wire goes all the way down to where the input is. Basically, I'd also wired the input to the wrong wire as well, so that's why I've had to cut the trace. And then obviously the input needs to go through a capacitor first, and then a resistor as well. So done a right bodge there. I totally cocked this up, I tell you, but never mind. I'll explain why I messed that up as well. Well, actually, no, this one is I just totally forgot because I was looking at the data sheet. Well, no, I wasn't looking at the data sheet, otherwise I'd have seen these. So I was just going off a project I'd done prior, and it didn't need these because these 2 components were elsewhere, and because I'd copied it off a previous project, I'd missed them out, and that's why I did that, why that happened. But that's now being corrected on the current PCB, which is, the current PCB is version 1.3. So yeah, so I can stick the knob on now because we're not going anywhere near there. So that just pushes on. There we go. That looks a lot better now with the knob, and this can adjust the speed. So what else did I do wrong? Right. Okay. So yes, my speed control. This error was a bit of because I'd sort of mirrored the 2 sides of this potentiometer, basically my big potentiometer is tapped into one side of this um, potentiometer here, and I put it on the wrong side of it, so basically I've had to swap that around. That was a bit of like mirroring. So yeah, that was easily done with a few wires. And my other one was behind, I don't know if you can see it behind there. Let's see if I can get that into shot. This is behind, this is my LCD, my OLED. I got the clock and the data the wrong way around. This was, although I had copied it correctly onto the fritzing, okay, right, but I forgot that I actually, I'll show you later, well actually I'll show you now, just a minute, I'll get that. Yeah, I've made some little modules, I've made some little stand for my modules, and this is one for the OLED, and because it's I2C, I have a standard sort of like pinout which goes onto my Arduino, and my Arduino always goes ground, VCC, data and clock. And I didn't realise on this pin, which is what I copied across to my PCB, is that back here I'd actually, let me just get that cable right so you can see, I'd actually swapped these two pins around, and I forgot about this, and so that's why I ended up with these the wrong way around, because it's actually the data pin that's on the outside and not the clock, and normally I have the clock on the outside rather than the data. So yeah, that was something I forgot I'd done. So when I had this plugged into my breadboard, I was using this layout, and so they ended up wrong. Anyway, I've corrected it on the new version of the PCB, and so yes, so what we have, I've got this plugged into my PC at the moment, and then we have 5 volts in. Oh, and the other thing about the LCD is I have some pull-up resistors. Now I was using 4.7k pull-up resistors when I was running it at 3.3 volts, but I've had to swap them out for 10k resistors now that I'm running it at 5 volts. So the pull-up resistors, I've increased the value of the pull-up resistors so it doesn't put too much current on the I2C pins. I mean, these actually internally, these, well, no, right, they run at 3.3 volts, but actually the screen actually runs at higher voltage, but these have been designed to work from either 5 volts or 3.3, and there's actually a linear regulator on there to knock it down to 3.3. But they've done some shortcuts on the pull-up resistors. There is actually some pull-up resistors on here, but they're not quite enough when you're running it at 5. So it's a good thing to put pull-up resistors when you're running at 5, but when you're running at 3.3, they can manage the pull-up okay. So when you actually, if anybody actually makes this PCB, you may need to play around with. I'll show you on the schematic later and come back to it. In fact, later on I'll come back. Well, no, let's go there now, because that's all done. That's all my mistakes done. It'll run off. It'll power one of these little speakers. Oh, and as I was saying, that I've used a different op amp. No, sorry, audio amp. But there's quite a few of these audio amps out there, and the pin configuration is the same. It's just the wattage that they use and can power, and the type of speaker. There's some for 3 ohm speakers, some for 4 ohm, some for 8 ohm, and so on. So depending on the chip that you use for the amp, you can use, there's a good range you can use. Right, let's get to the circuit diagram. Yeah, here's the circuit. So as I was saying with the operational not I keep saying operational amplifier. The audio amplifier, I had wired it up wrong, and I'd forgotten these two components, this capacitor and this resistor. Now this resistor acts like a bit of what can we say, a voltage divider, because it goes to the in pin there, and also the feedback comes through as well. Now this is, I've got this down as a 20k, and I only had some 22s, so I stuck a 22 in here, and I don't have any of these 2008 amplifiers either. I stuck, like I said, the LM whatever it was in there, which is a lower wattage, and so you can play with this. If you look up the datasheet, you can have a play with this. It depends what speakers you've got on there, and you can have a play with this resistor. And I started off with this resistor here to match that one, so it's basically half in the voltage. But I've tried it with a 4.7k as well, so you can swap this one out as well and try changing that one there to see what difference it makes. I reckon you look at the data sheet to see look about these resistors, but anyway, you can mess around, shall I say. And this capacitor, well, I just put the biggest one I had in there. I think I put 100 nanofarads in there, I think. So that's another one you can play around with as well. But basically these amplifiers will just about work with anything. So no, I better not say that. Anyways, look, if you look at the data sheet, but you can swap it out, and I think you'll find that a lot of these amplifiers have the same pin out, so you can get what you can. If you want to, if you've got money's no object, get a right good one and a powerful one. But like I said, I haven't put a heatsink on the back on the PCB. I haven't fitted this yet. This is that big massive capacitor. It's because we're using a good a motor with some a decent amount of current. It may be a good thing to add. The driver was okay, that was fine. If you find that the driver is driving the motor the wrong way, all you do is you switch that, it plugs into your connector that plugs on there, you just flip it over and it'll go in the opposite directions. And that comes down to the clock and data. So basically this is what I've changed, these two here. So depending on there's a lot of these OLED modules about, and many make them, and some have a lot of components on the back, some have very few components on the back. So some take shortcuts and some don't. So you maybe want to try messing with these. So well, basically it's either 10k or 4.7, whatever works best for you. Like I say, my code for the I2C, I've put a delay in there for it set up, but I'll show you that when I actually come to play it. We'll play the record again once at the end of this video. But I just wanted to mention these things so you're aware. These are just current limiters, so I'd leave them at 100. But it's these two here that you change for the pull-up resistors to pull the clock and data lines up. So what I'll do is I'll just bring up a picture of the OLED. Yeah, so just to be sure that we're using the same OLED, it's I2C, and it goes ground, VCC, SCL and SDA. That is the order in which these pins should be. There are others that have either these two switched around, or they have these two switched around, or they have both switched around. It all depends who do it. I just wish they'd stick to a convention that when using these I2C things, that they go ground, VC. Well, actually, I prefer these two switched around, actually, so that goes with the colours of my wires. Well, it goes with the bus I put on my Arduino. Anyways, I just wish they would stick to one, so then we all don't get messed up like I did. Right, so yes, that's it. That's all the notes I wanted to make. I will set up the record player. Right, as I say, we can play it out of one of these little speakers and just plug that into there. Well, get my hand out of the way. Plug that into there. But as you won't be able to hear that, I've plugged this lead into my auxiliary in my computer, and so we have a two-way switch. In the middle is off, and if I switch it to this direction, it just turns on the drum and we can set the speed. Oh, this is what I'm on about the voltage difference. Just turn it off and back on again. Hopefully it'll sort itself out. Maybe the capacitor, big capacitor, will help that, I don't know. But anyways, so we can see the speed. Let's just see if I can focus on that, because that's the one we want, isn't it? Oh, it's a bit dark. Try that. Look better. Yeah, I always mess up the light, don't I? Yeah, that'll do. Oh, it's a bit too bright. Try that. Right, I'm going to stop there. Right, that's okay. So yeah, the speed these run at is 160. So we can just turn this knob. Oh, I just tapped it, but anyway, there. So there we go. 159, 160. Let's just try and get it to stick on 60 and just turn it a little bit more. How's that? Oh, 60, 61. Let's go back a bit. There we go. Bit more. There we go. I think that looks alright. And then, like I say, if we go the other direction, that's going to sort of do the turn on the stylus control for the arm. So I'll just go the other way. Actually, is that actually working? Yeah, there we go. Yeah, so oh, hang on, I just need to turn the auxiliary on. Just turn the auxiliary on, and I'm going to shut up and let it play. So one moment. we go. You know, I think I might fit that capacitor. I shouldn't have to adjust it that much. Just turn that up. Nope. Oh, actually, I wonder why that buzz. I got hum there, right? Let me just turn it back on. And the hum's gone. Oh, right, I know why. Because I haven't got power to the. I haven't got power to the audio amplifier. I might do that in a revision, but anyways, for now, now I know why it's humming. So what I'll do is I'll just leave this at this end. Yeah, I think what I need to do is keep power onto that amplifier. Yes, that's just like another, like I say, you're prototyping. It goes through various revisions. So well, I'm going to add that capacitor and see if it makes any difference to the stabilisation of the speed. Just before I fit it, I thought I'd show you how I'm going to fit it. I sort of drew it so it would go down there like that, basically. But the way it's fitted on my machine, I think what I might do is I'm going to go for that. Put it there like that, so that when it's in the machine, it'll sit below here, out the way. So it's going to come under there, oh, I can't see my hands. It's going to be sort of underneath. Anyway, yeah. So that's like that basically. So this is going to go like this. There. So I'm going to fit it like that, and then it'll fit along there and miss everything else underneath. Okay, I'll just do that. Okay, there we go. So I've fitted the capacitor, and it's just, see it underneath here, which is okay. And well, we're going a little fast there, so let's just see if we can get it a bit closer. I don't know where it is, but if you leave it running for a while, it tends to sort of, whether it's charging this or not, I don't know, but yeah, it's a good thing to sort of just let it sit there and settle for a while. Especially if you're going to do some recording or anything. Anyway, I'm going to shut up and we'll change it over to the other thing. Put in its play position. Oh, sorry about that. Oh, yeah. I don't know if I'll get in the groove. Right there, so we're finished. Oh, I'll mute the thing. There we go. Yeah, so there it is, all finished. Well, everything has places of improvement, but the originally I just set myself a challenge to make it and see if I could do it. That's all. You may have noticed that there is some clicks towards the end, and where's my hand? Get me pointy hand. There. Can you see this scratch? That's my fault. Well, I think it's my fault. This is the only record I've got, and when I had to make some right close measurements, and I slipped when I was measuring it with something metal, and it just put that little gouge in it. It's a shame, really. Let's say a language flu. Anyway, well, I hope you've enjoyed the series, and I'm going to call it a day, guys. So thank you for watching, and if you made it all this way and watched them all, thumbs up to you, and let's see what my next project's going to be. Anyway, when I think of a new project, you'll be the first to know. Catch you later.